All right, so let's look at another one. We've got a negative 10 KSI stress in the x direction. I got negative 16 KSI shear stress going on, and then nothing in the y. So again, the simplest thing to do is to start off with our calculation of where our centroid is going to be. So 10 divided by negative 10 divided by 2 is negative 5. So our centroid's going to be there. Our radius, so again, the negative 10 plus minus the negative 5, so negative 10 plus 5 squared, so 5 squared plus the 16 KSI squared, so take the square root, that gives us 16.67 KSI. So that's going to be our radius, and again, that is based upon the location there is based upon this face at this point. So our principal stresses, sigma 1 is just the negative 5 plus the 16.75 gives us 11.7, sorry, 16.76 gives us 11.76 KSI. The sigma 2, that's just going to be the negative 5 minus the 16.676, so minus 21.76. So how to get from here to here? We're going to need to rotate. So how much do we rotate? Well, I guess that depends on what this angle is here, right? So we can figure out what that angle is here just by taking the inverse tan of the 16 and the 5. And that gives us twice what our angle of rotation to get to the principal axis is. So if we need to get to our principal to where our prime stresses are, that's our principal stresses. That's going to be 36.3 degrees. So yeah, here we go. A square that's rotated 36.3 degrees. So again, to go from this point to this point, we're going to need to be rotating. That's counterclockwise. So to go from this square to that, we rotate this counterclockwise. So, and again, to figure out kind of which face is which, the one that started out with the negative 10 KSI on it grows to a negative, and we start out here, we rotate down here, and the compressive stress on that one grows until we hit its maximum. So it grows to 21.676 KSI. So that started out on this face here, and then we rotated it a little bit. So that means this face here corresponds to this face here. So we got the 21.76 KSI on these two faces, and then the other pair has the 11.76 positive tensile stresses on them. And then for our maximum shear, again, the amount that we need to rotate is just 45 degrees off of that. So 36.3 minus 45 degrees gives us 8.7 degrees. 8.67 I put here, but anyway, 8.7 degrees is going to be how much we need to rotate our square clockwise in order to get to where our maximum shear is. So again, that'll be at the negative 5 KSI is going to be the x coordinate of that, and then the y coordinate of those is going to be at the it's going to have the same magnitude as radius, so 16.76. And again, for our directionality, so all four faces are getting a compressive 5 ksi, and all four faces have a 16.76 ksi shear stress on them. And if you want to make sure you got your directionality right, if we started out with the original square, and that was at that had on its positive x face, it had a downward 16 ksi. So that started off as downward, and we're rotating a little bit in order to get to where its maximum is. This face corresponds to that face. So the shear stress on this face is the same directionality, just a bit larger than the shear stress on this face. So therefore we know that a directionality on all the faces go like that. And that is about that.